This video follows on from the last core experiment we did, where we were trying to produce a soluble salt starting with an insoluble reactant. So in that experiment, we started with copper oxide. Now the copper oxide is insoluble; it's a solid. We reacted that with sulfuric acid, and that made copper sulfate. And water. Now, the copper sulfate is aqueous and the sulfuric acid is aqueous. So to get the pure, dry sample of copper sulfate there, we started with loads and loads of copper oxide, excess, too much copper oxide. So that made sure all the sulfuric acid was used. So then we had, in a mixture, copper oxide and copper sulfate, and the way we got the insoluble, the solid out, is we filtered it. And that left us with just copper sulfate and water, and we evaporated the water. Okay, now in this example, we're starting with two soluble reactants. Okay, we're starting with sodium hydroxide and hydrochloric acid. Sodium hydroxide is aqueous. Hydrochloric acid is aqueous. And that's going to make sodium, that's an arrow, that's going to make sodium chloride, which is aqueous, and water, which is a liquid. Okay, so we have a problem here. So aqueous, we have a problem here in that we can't start with an excess of one of these. So we start with an excess, that leftover reactant will be mixed in with the product, the salt produced with sodium chloride. So we're going to try and produce a pure dry sample of sodium chloride. Why can one of the reagents not be used in excess in this scenario? If a reagent is in excess, it will be mixed with the product. Okay, so the only way out of this is to start with exactly equal amounts in terms of particles of sodium hydroxide and hydrochloric acid. So when we react exactly the right amounts, there won't be any of those left over because they'll all have reacted. It will just leave us with sodium chloride and water. So the way we do this is we need to carry out a titration. Now, if you're a triple chemist and you are going to do the single chemistry GCSE, in the extension unit, the triple chemistry unit, we do study titrations in more depth, and there is a video about of me carrying out a titration that you can watch about this. I'm just going to talk through the apparatus in this, and not show you the apparatus because we'll look at that later on. So the apparatus we need, first and foremost, is a burette. A burette is a very long, thin glass tube. Okay, it's very long and very thin because when we add a little bit of liquid to it or run a little bit of liquid out of it, it makes a big difference to the height. So we can see the height change. So basically it allows us to measure out liquids quite precisely. Now it has a tap on the bottom of it, so that's what that is there. A circle with a cross going through it, and just make the spout come a little bit longer. At the bottom down here, we're going to have ourselves a conical flask, and that's what we're going to carry out the reaction in. Now remember, what we're trying to do here is measure out exactly equal amounts of hydrochloric acid and sodium hydroxide. So to do that, we need to have one of the reactants in this conical flask at the start of the experiment. And what we're going to have in there at the start of the experiment is sodium hydroxide. And we need to measure that out really accurately as well. So to measure that out really accurately, we're going to use a pipette. Now, a pipette is an even thinner glass tube. Okay, an even thinner glass tube than the burette. It has a big bulb in the middle of it, so we can get a lot of liquid in there. And these bits of glass are very thin indeed, so a tiny bit of liquid makes a big difference to the height. Now they have a line at the top there, and the idea is we suck up, we have a pipette filler on the top, which allows us to suck up exactly 25 centimetre cubed. And you can have pipettes of different sizes. It allows us to suck up exactly 25 centimetre cubed in this case of sodium hydroxide. So in here is going to be our sodium hydroxide. So once we've sucked that up there, we put that into that conical flask there, and that's that sodium hydroxide there. So that's exactly 25 centimetre cubed. The acid is going to go straight into this burette. Put the acid in the burette. Okay, so what we're going to do, so we've got our sodium hydroxide down here. Let's label it all up now. Sodium hydroxide. Okay, it was in this beaker here, and we measured out exactly 25 centimetre cubed. Exactly 25 centimetre cubed. And in here we have our hydrochloric acid, So this piece of kit here was called a pipette, and this piece of kit here is called a burette. Okay, now what we're going to do, now we've got this sodium hydroxide in here, we're ready to start the reaction, or are we? How will we know when everything's reacted? Well, sodium hydroxide is an alkali, pH 13, hydrochloric acid is an acid, pH 1 to 2. So we need an indicator to tell us when they have exactly neutralised. So the indicator we're going to use in this one is going to be phenolphthalein. Phenol, P-H-T-H-A-L-E-I-N. And phenolphthalein is pink in alkali. So you add it to the sodium hydroxide and it's going to be pink. Pink in alkali. And then we're going to run in the acid. And what we'll do, actually, just before we start this experiment, we're going to put this sodium hydroxide on a white tile. Okay, on a white tile. So we'll just indicate that like so. Now, we put it on a white tile because that way we can see really clearly against the white background any colour change. That's on a white tile. So we're now ready to start running in the hydrochloric acid. So we turn the tap here, the hydrochloric acid starts to run in, we swirl this around. When that goes colourless in acid. The second it goes colourless, we turn that tap off and we have got an exactly neutral solution. At that exact moment, every last bit of sodium hydroxide has reacted with hydrochloric acid, leaving just the products. There's no excess reactants, just the products. And you may say, oh, excellent, right, we can now evaporate off the water and we're left with sodium chloride. Well, close, but not quite, because we've got phenolphthalein in there. So it's not quite pure. So what we would do, this burette has readings down the side of it. So we're going to read off exactly how much hydrochloric acid we added. Exactly how much. And then we chuck this away down the sink. We measure out with our pipette another exact 25 centimetre cubed. This time we don't add any phenolphthalein. We top the burette back up and we add exactly the same amount of acid as last time. Okay, now once we've done that, we know, because the last experiment told us, that will be an exactly neutral solution. And then we can evaporate the water, and that will leave us with just sodium chloride. So that, in a nutshell, is how we do that experiment. What you do next is write a really quick method about that. And that's what we'll do now. So number 1, fill burette with acid. Number 2, measure exactly 25 centimetre cubed alkali with a pipette. Put alkali in conical flask on a white tile under burette. Add a few drops of phenolphthalein phthalene indicator. 4. Add acid until indicator turns colourless. Important there. Number 5. Empty flask and refill with another 25 centimetre cubed alkali. Number 6. Do not add indicator. Now you won't be able to see the neutralisation point this time. That doesn't matter because we're going to add, number 7, add exactly the same amount of acid. Number 8, evaporate the resulting solution, and you will end up with pure crystals of sodium chloride. Why is it necessary to do the first titration with an indicator and the second titration without? Number 1, to see neutralisation point. Number 2, to get a pure mixture to evaporate. So we do the first experiment so we can see the neutralisation point with indicator. Second one without the indicator so we get a pure mixture to evaporate. Once the second titration is complete, what is in the conical flask? Answer: sodium chloride and water, both products. How do we get just the salt? Answer: evaporate the water. And that is how we get a pure dry sample when we start with 2 soluble reactants.